I just enabled the recording function, so we are recording as of this moment. I want to, oh, we still have people joining in, so let me go ahead and admit those people. I want to welcome everybody that just joined or that joined a few minutes ago. We are about to begin this particular boot camp. This boot camp is called Welcome to the Checkpoint Fast and Furious AWS Bootcamp. It is intended to be an AWS hands-on lab for architects, engineers, analysts, and enthusiasts in general. Everything that you will see is based on our normal bootcamp lab guide. I am going to make the link to the lab guide available to everybody in this call so you can download it. We are deviating from that lab guide. We're deviating because the lab guide is made for in-room classes that have access to a lab environment provided by Checkpoint. The number of people that registered for the bootcamp doesn't allow us to do that. So we made some changes. We requested that everybody that wants to do hands-on today have access to their own AWS account. If you do not have access to your AWS account, do not worry. Every single exercise is going to be done on the screen. So you will see everything, every step that is in the guide. We're going to go through it on the screen step by step. So even if you do not have access to an AWS environment, you can follow via the screen, and you're going to get a copy of that. So later on, you can play it back and go step by step through all the exercises on your own later on. So if you want to follow on your own AWS environment as we go along, you're more than welcome. If you just want to watch, that is also perfectly fine. We are going to have a couple of breaks. Usually, I put the breaks about 1 hour in, and then after the second hour, I'm going to put a second break to give people time to stretch their legs, do a bio break if necessary, and then I'm going to renew the session. So I'm going to begin by posting a copy of the link to the guide. So let me just get that from here, and I'm going to post this on the chat. So everybody can simply click on it if they so wish and download the version of this guide. It's in PDF, so I'm going to put it in there. I'm probably going to paste it more than once because some people that join later on will not be able to grab a hold of it. That guide, again, has some differences from what we're going to do today, but it does go through most of the environments and exercises the same way. And I'm still limiting people, so I'm going to paste that guide again in a few seconds. Okay, to everybody that just joined, I am pasting on the chat a link to the lab guide for the hands-on exercises that we're going to be doing today. If you do not have an AWS environment of your own that you can use to follow along on your own environment, you can follow along on the screen because I will be doing all the exercises on the screen and showing them to you. The reason we normally encourage people to do it on their own environment if they can is because as you do it on your own environment, you may run into things that are not, that won't be present in the lab environment that we're using. So I can answer questions about any specific errors or specific conflicts that you may be seeing. If you have questions as we go along about any of the exercises or the pieces that we're going through, by all means, do place them on chat. I will request that you use the chat while the exercises are going, but you can also always unmute at the end of the session. Once we go through all exercises, I'm going to open for Q&A, and we'll have that part pretty much live. In addition to that, I'm also going to add to the screen links to the recorded exercises. So everything that you're going to see here is actually pre-recorded, which allowed me to do this in case something happened, which prophetically did yesterday. There was an outage in AWS. It would have not affected us had we done this yesterday, again, because I have links to recordings of all the exercises. I put those links on the chat as well. You do not have to go into those links today. We're going to be going through those links one by one, and we're going to be talking about all those steps in the exercises. But I wanted to make sure that you could sort of go to a specific exercise if you wanted to. You can jump straight to it. These are YouTube links. So there's going to be YouTube ads associated with them. I apologize for that. I could not find a private platform to share the videos with you that would not expire after a few weeks. I wanted to make sure that you have access to these videos for as long as you need access to them. Okay, so with that said, I'm going to go ahead and start the presentation. Things have stabilized a little bit. I think we have most of our participants in already. Again, my name is Gus Cornell. I am a cloud architect for Checkpoint in the North America theater. This is my email address. If you want or have technical questions about any of the things we touched upon today, or anything really in the AWS, Azure, Google, Oracle, public or private cloud environments, please send them to me. That is my job, to answer technical questions about cloud for customers. This is also my phone number. I request that you please text. If you use that phone number instead of calling, I am on the phone almost the entire day, every day. But I am able to see any text messages or questions sent that way. So I'll be glad to answer them that way as well. Email, of course, is the preferred way to communicate. This is the agenda for our bootcamp today. We're going to review the general concepts for the CloudGuard gateways in the AWS infrastructure. And then we're going to go into the lab and show you some of the exercises from the guide that I posted, done step by step on screen, so you can see all the steps. We're going to start very, very basic. So if you are already familiar with AWS, you know how to create VPCs and subnets, please don't lose patience. We're going to move through that very, very fast. But I wanted to make sure that everybody, no matter what the level of knowledge in AWS, it has a chance to follow along. We have multiple solutions that help secure AWS for customers. Those solutions include security systems that look at the network packets as they come in or move inside of the cloud. We also have solutions that look and control what the people that have valid user IDs and roles into public cloud can do. And we also have solutions that address the control plane and changes that people can make at that level in AWS. We're going to be spending most of our time at the beginning on the network piece. There is some for the control plane, and we will be doing that after we finish all the exercises for the network piece. I want to give you an idea of what the control plane solution looks like. There are a few exercises on the lab guide that you got that are geared to try to give you access to that control plane solution. It will not work on your own AWS environment. So we're going to skip those exercises when we go through, but I'm going to show you live on screen what that looks like as well. I'm going to summarize real quickly the Checkpoint Cloud security solutions that we have. We have 5 different solutions to address all sorts of attacks and vulnerabilities that come in the cloud. We're going to spend most of our time today on the cloud network security piece. Again, this has to do with packet inspection. So we are inspecting, looking, detecting, and stopping attacks that come in through the network via packets, whether that is from the internet, whether that is from internal networks and internal users, whether that is from one side of the cloud to another side of the cloud. Our solution looks at packets coming in from outside, inside, and that move laterally on the cloud system. The second piece of today is going to be a little bit on cloud security posture management, and we will talk about why that is needed, and you will see why it's needed as we go along on the first piece. But that actually helps you control and give extra visibility into the cloud. We also have solutions that address containers and workloads and serverless code in the cloud. We will not be touching on those as part of this bootcamp, but we have those available, and you can, if you have questions about those, please feel free to reach out to me on them. We also have a next generation WAF as well as an API security gateway. APIs are being used a lot in the cloud for pretty much everything. So we have a next generation piece of technology that is also packet inspecting, that looks at the API calls. It's looking for attacks that come in via APIs. So that again is another solution. We will not go into that solution today. But if you have any questions about that, please reach out and we'll be glad to talk about those. Finally, we have intelligence and threat hunting, which has to do with enriching and analyzing cloud activity and cloud traffic. We will be touching a little bit of this on the second half of today. So these top three things are probably the ones that you're going to see today. This one is the one we're going to start with, and is going to be the one that we're going to spend most of our time in. That is what the lab guide is usually about. The first question that I normally get whenever somebody asks me about securing AWS is, how is the Checkpoint security gateway different from the security that AWS already allows and gives to customers? That includes some very powerful security solutions. They have a pretty good managed firewall that does IPS and IDS. It also does basic URL domain filtering. Of course, they have their NAT gateways to protect outbound traffic. They have Macie for DLP. They support packet capture and mirroring into certain systems. They have security groups and NACLs, as well as a WAF solution that can get deployed via their load balancers. These are fairly good capabilities. I am a little disappointed at their managed firewall because of their GUI interface, but it is a very powerful managed firewall. So the question that I normally get is, what is our value added to this? This is what your security capabilities would look like after you add CloudGuard on top of the security provided by the AWS systems. In some cases, we totally replace, or are able to totally replace, and add additional capabilities beyond the system. A lot of these are unique to Checkpoint, and they don't have an equivalent in the AWS environment. So most of the users bring Checkpoint into the environment because they might be looking for one or two of these specific ones, maybe malware detection, maybe zero-day threat. Maybe they want to be able to use tagging as part of the source and destination. And we're going to see a little bit of that in today's bootcamp. But the nice thing is that once you bring in CloudGuard, this is the general license. So when you bring CloudGuard in just for one or two things, you basically inherit or allowed all the other capabilities as well. Okay, the second question that I get asked is, how does Checkpoint normally get deployed in AWS? So I talked about the security blueprint. And the security blueprint for Checkpoint works a little bit like a castle. So you have your networks in AWS, and we want to build some sort of a castle wall around those networks. And if you notice, this castle has two entrances, has an entrance on top and an entrance on the bottom. The entrance on top is to allow people coming in from the internet to come in into your internal networks. The door on the bottom is to allow people that are part of your internal network. Maybe there's a city, a town that's protected by the castle, and people from the town can come in and out of the castle through the back door. The inspection on the back end and the inspection on the front end are usually different because there are different types of traffic coming in. You do not have to have two separate entrances, one for public traffic and one for private traffic, but it is the best practice usually for most implementations. And with that, I'm going to show how that will look, that the castle wall would look on an actual infrastructure diagram for AWS. And we have a couple of ways that we deploy, but basically what we do is you have your own VPCs, where there can be production, non-production, shared VPCs. You may have VPNs or SD-WANs or direct connect attachments to that central transit gateway hub. Maybe you're coming in into those systems directly. What we do is we build those doors that we showed you, an ingress door for traffic coming from the internet, an internal one for traffic coming in from the internal networks. And then we use the TGW to reroute traffic coming in from the internet or coming in internally through the checkpoint inspections doors or gateways before they go to the ultimate destination. So if somebody in production wants to talk to somebody at headquarters, they would move through the TGW. They would be sent through the checkpoint guard gate for inspection, which would then forward to the correct place. Same thing on the other way around. If we're moving from one VPC to another, same thing. The VPC, the source VPC will send to the TGW, that will send to the checkpoint inspection, which would then forward to the TC in question. If something comes from the cloud, it will normally hit the ingress piece. It would hit the public load balancers, which in turn would hit the checkpoints, we would then forward it to the correct place. Now, we have two favored checkpoint deployments in AWS, and I'm going to talk a little bit about both of them and the difference between them. This one is called the Cross Availability Zone Cluster. This checkpoint pair is an active standby pair, and it has full stateful awareness between them. So these two firewalls are sharing state. They're also across availability zones. So if an entire availability zone fails, you have a secondary availability zone that is available. This failover is automatic and it happens inside of 5 seconds. The failover is also stateful aware. So if you have legacy applications, all applications that require terminal sessions, or maybe RDP sessions because you're using RDP to manage maybe workloads up in the cloud, stateful failover is usually a popular requirement because if one of these gateways goes, the sessions will transparently migrate. Things will seem to pause for about 3 seconds, and then everything will keep on going the way that it was before. So the cross availability zone cluster is very popular if you need stateful failover of your traffic. Now, if your applications are fairly modern, you don't have a lot of legacy applications, but they're mostly web-based, and the web sessions maintain state by using cookies. They have session cookies. So it doesn't matter whether a session was ongoing through one gateway or another, then you can use the gateway load balancer solution. The gateway load balancer solution is scalable, which is a difference from the active standby stateful. However, if you have stateful traffic, it will be interrupted if one of your scale set gateways dies. Because when you have an auto-scaling group in AWS or in Azure for that matter, or Google, or pretty much in every one of the clouds, we are not able to do the stateful sync, the syncing or sharing of state between the active systems, mostly because we have a lot of systems, they're all active at the same time. So we cannot do that stateful failover under this scenario. Again, if you have modern applications that use webs and cookies, it is not a problem. You can start a web session through one gateway. That gateway may save, and your browser has everything that it needs to continue that session through the other gateway. However, if you're running an RDP session through these, if you're running an SSH session through these, if you're running an FTP transfer, something like that, if one of these gateways goes, your connection will break. Because again, we're not sharing state here. So if you're starting an SSH session, you will have to restart it. If you're running an RDP session, you will have to restart it. So this is much more extensible. It is much more powerful, but you lose the stateful failover that this one gives you. The biggest issue with this one is scalability. Since you only have 2 gateways, one gateway active at a time, the maximum amount of traffic that you can put through the system is the maximum amount of traffic that we can push through one gateway. In AWS, it's about 10 gigs. So if you have up to 10 gigs and you need stateful failover, you can deploy the cross availability zone cluster without any problem. If you're going to be exceeding 10 gigs, then you need something that can scale upwards. This system can scale well beyond the 50 gig burst attachment capacity in the AWS TGW. So it can very much handle almost all the traffic that you can send to it. Finally, in here, before we start our lab, I just wanted to point out that the CloudGuard blueprint is multi-cloud. So if you deploy both AWS and Azure, you would have very similar deployment philosophies. The biggest difference between Azure and AWS is the existence of the TGW hub. You can just do a direct peering in Azure without the using that gateway. But the bottom line is the same. You have one hub for internal traffic, one hub for external traffic, one hub for internal, one hub for external. And they can all be managed from a single manager that can be either in the cloud, in either one of the clouds, or it can be on-prem. So we don't care if you have virtual gateways in VMware, virtual gateways in Cisco ACI, virtual gateways in Azure, virtual gateways in AWS, in Google, in Oracle, in Ali Cloud. All of them can be fully integrated to a single manager and can be managed from a single place, either on-prem or on any one of the clouds. Okay. With that said, I'm going to talk a little bit about our lab. Our lab today is going to involve a deployment of a cluster pair in AWS. We are going to be creating this environment. We're going to be deploying the cluster. We're going to be deploying a manager. We're going to be deploying a web server, and we're going to be routing traffic from the internet through the cluster up to the web server. Again, all the exercises that we're going to be going through are in the lab guide. This is the link to the lab guide. I'm going to put the link on the chat once more for people that join after we started, so they can download that if they need to or they want to. Even if you do not download the guide, you will be able to see all the exercises pertinent for today, because I'm going to be doing those exercises live for the entire audience today. I'm also providing links for each one of the exercises that we're going to do today. These are recorded exercises. They're the same links that we're going to use today during the presentation. The reason I broke it down this way is because maybe you're trying to do everything on your own. Maybe you're stuck specifically on exercise 5. Maybe you're stuck on exercise 2. And you want to be able to look at just that exercise piece. You can go to the link directly and just see that piece. Notice that there's no exercise 3. Exercise 3 is missing because it is to deploy a posture management solution on our in-house environment. It will not work with external AWS accounts. So I skipped exercise 3, and what we're doing is I'm going to be adding a demo after exercise 5 that goes specifically or addresses specifically what that exercise 3 was going to show to begin with. Okay, so let's go ahead and start our environment. I'm going to start with exercise number 1. Again, I am just using the pre-recorded sessions that I had from from a few days ago when I originally went through these. You will see some ads. I apologize for that. Hopefully, I'll try to keep those to a minimum. But I will be pausing through this, explaining what is happening. If you have any questions about the exercise as we go along, feel free to add those questions in the chat. If you want to follow along, you can actually do these exercises on your own environment without any problem. So with that said, let's admit somebody else that wants to come in at this point. I am going to go ahead then and start this. None of these videos have any sound, so if you download the videos or you try to watch the videos on the internet tomorrow or next week, no matter how much sound you put on, you will not be able to have any sound. But this bootcamp is being recorded with my voice, so you will be able to play this bootcamp back later on. We'll send you the link to it, and you will have access to all the sound from my explanations at that time. So the very first exercise is building the AWS environment that we're going to be using for our lab. It is a very simple environment. Again, we just want to do the basics here so you know the basic steps. Whether your environment is more complex or not, it should not make a difference to some of these deployments. So the first thing I'm going to do is I'm going to go to the VPC section after logging into AWS, and I'm going to launch the VPC wizard, which is going to be available to us from there. From those, I'm going to use the very first one, which includes a public subnet. That means that we're going to get an internet gateway already attached to this VPC, which is what I want. The name for the VPC is going to be AWS training. You can change the name if you want to. I'm going to be doing this on US East. So you're going to see US East is over here. By the way, you'll probably know that there were problems with US East yesterday. If there are still problems with US East today, you do not have to use US East for these exercises. You can use any region in North America for them, any region in the world. The steps are going to be basically the same. After the VPC comes up, I am going to check and make sure that the VPC got created with the correct number schematic. By the way, the lab recommends that you use the 10.0.0 CIDR block. You do not. Again, all exercises will work even if you change the CIDR block to any other one that you want to use. I'm going to follow the lab guide as close as possible, mostly because it lets me refer to the guide back and forth. So I'm going to create a second subnet. In addition to the public subnet that was created, I'm going to call this a private subnet. I am creating two subnets because the checkpoint clusters, the active standby, the single gateway solutions, all have two interfaces associated with them. So we need one public side to the interface and one private side. I am creating a second subnet so we can have a connectivity to that private side as well. Let's see. After the private and the public have been created, I have what I need to deploy with one last thing that I need to check. A route table should be created for us automatically by the wizard, but I always double check that it's there because the public subnet has to have access to the internet. So I go to route tables, I click on the second route table. The first one is going to be main. That's not the one that I want. I want the other one. That's the one the wizard created for me. And what I want to see is I want to see that quad 0/0 pointing to the internet gateway, because that means that anything that I deploy that is connected to that subnet will be able to reach the internet. We need to be able to reach the internet because we are going to be we're going to be giving a public IP to our management server. The reason I put a public IP to the management server, at least during labs and boot camps, is it makes it very, very easy for me to reach out and connect to that management server over the internet. You do not have to deploy a management server with an internet connection. You can reach to that manager internally via a direct connect, via a VPN. However, having that public IP is something that makes it really, really easy to directly connect to the manager if it's in the cloud. And there might be some issue. Maybe the VPN went down. Maybe having issues with direct connect. Maybe have issues with routing. I can hit that manager directly. You can also choose to have a Bastion host. If you're going to have a Bastion host to reach the manager, I recommend that the Bastion host is a Windows system, because we normally connect to the manager using two things. We connect to the managers using SSH, but we also connect to the manager using Smart Console. Smart Console is a Windows application. So if you're going to be coming to a Bastion or a Job host to connect to the manager remotely, you want something that has a Windows operating system. So you can both do SSH into the manager, and you can also do Smart Console into the manager from that Bastion host. After we check for our routing tables, we are going to create a key pair. You may already have a key pair created. If you don't, you can create one specifically for the checkpoint manager and checkpoint gateways. The lab calls that key by key pair. Notice that you have a choice. You can generate licenses using the .pem or the .ppk format. This only depends on the client, the SSH client that you're going to be using to connect. Some clients, for example, PuTTY, want the keys in PPK format. Others want it in PEM. I use MOBA Extern myself, which doesn't care. It will work with PPK or PEM keys. But that is what's going to define the key that you're going to create, whether you're going to be using PuTTY or some other system. When you say create, it will download the key to your downloads folder. And from there, you can access it later on when you connect. So I'm going to go ahead and close this and ignore this for now. We'll get to that in a second. I'm going to go ahead and go to exercise number 2. So let me open that hyperlink. And let me pause it here before we begin. Exercise number 2 is going to be deploying the management server into our environment. We're going to be deploying the management server into our public subnet because if you remember, the management server is going to have a public IP that is going to allow me to connect to the management server directly. We just verified that the public subnet has a route to the internet, and that route is pointing to an internet gateway. So I'm going to go ahead and deploy my management server. Now, if you look at the lab guide, the first thing that it says is to open your browser and connect to this link. That is not the first step. I added what the first step should be, and you should always check on this first. So the first thing I'm going to do is we'll eventually go there, but I'm going instead to go to AWS. I'm going to launch an instance. I'm not really going to launch it from here, but I'm going to say that I am, or act as if I were. I am going to go to the AWS Marketplace. I'm going to enter Checkpoint. I misspelled it, but I still found what I wanted. What I wanted was this, the Checkpoint Security Management with the bring your own license model. This is what we're going to be deploying today. And the reason I'm coming here first, instead of going to the link that the lab says, is because we need to enable the terms of service. And you do that by pointing on that link that you saw there, clicking on this continue to subscribe button, and that's going to show you a page that has this button right here. We need to accept terms for the checkpoint images manually. If we do not do this, the CloudFormation templates are not going to work because the CloudFormation template cannot sign or accept terms of agreement for you. This is a legal contract. This is not just Checkpoint. Any vendor that you deploy will have some sort of a terms and conditions to it. They want you to accept terms. Some of them may not care to have those terms automatically be accepted by a CloudFormation template. In our case, we want an actual person to accept the terms. So you have a chance to read the terms if you want to. This is just a regular software terms. They are no different from the licensing terms from our regular physical checkpoint gateways. But I always tell people, if you do not go through this exercise and press this accept terms button, the CloudFormation template is just not going to work. It's going to roll back and say that you have not accepted the terms for this particular image. So I'm going to click on that accept terms button, and then I can go away. I can leave here. I don't need to be here anymore. And I can click on that link in your lab. That link in the lab is going to take us to the Checkpoint support site. You do not have to follow that link. You can just come in here on your web browser and type support.checkpoint.com and then type CloudFormation. CloudFormation is what we're looking for. So you're going to see that the link that says CloudFormation templates, and we're right back here. This is the same place the lab link is bringing us to. So we're going to go down and we're going to be looking for a security management server. That's the link right there. I'm going to click on that. That's going to jump to the place on the page that has it. We can deploy management servers from here. We can deploy them directly from the marketplace. The reason we're deploying using CloudFormation is because CloudFormation is going to do a lot of the work of setting this up for us. Do we have to use CloudFormation? No. You can deploy the management completely manually from the marketplace. That is a valid option. You can also use Terraform. If you notice, I'm going to be using CloudFormation stacks for this, but you'll notice that this page also has links and access to Terraform. So if you like to use Terraform, if that is the normal way you deploy systems in the cloud, you can download the Terraform link. You can use it as a template for your own. You can modify it or run it as is. And you will be able to use Terraform to deploy the system. We will be using CloudFormation for this lab. So I'm going to go ahead and click on Launch Stack. I'm going to launch the one for R80 or higher because I want to use R81. And that's going to bring us to the CloudFormation section of AWS. If you're logged into AWS, this is going to open directly on the correct account. I'm going to give a name to my CloudFormation stack. It's going to be for the CP manager. I'm going to choose my VPC, AWS training. If you remember, we need to put a public IP on it. So I'm going to be deploying it on the public subnet. I'm going to change the name of my instances. I don't have to. I could use the ones that are the default that is there. On the instance type, we want to use M5 X large because it gives us plenty of horsepower to running the manager. You might be able to get the manager to run on an M5.large if you want to. It is going to be a tight squeeze. It's just two virtual CPUs, which is not the issue. The issue is going to be the memory. An M5 large has barely enough memory to run the manager. So we normally want that to be a little roomier. If you want this to be your manager on-prem, you can use your management on-prem instead of this. There is a question asking, can we get a demo license from Checkpoint to deploy these? If you deploy the Checkpoint images that we're deploying today, if you notice that they say BYOL, the BYOL comes with a free Checkpoint license associated with it. It is a full license that allows for everything to run. It lasts for 15 days, and you can reach out to your Checkpoint team if you need to extend that in 30-day increments. If you would like compute credits in AWS, because you're going to be deploying these in AWS EC2 instances, so there is going to be a compute charge in addition to the Checkpoint charges. There's going to be a load balancer charge if we're deploying load balancers. So if you want compute credits, we will be giving compute credits to people that have joined this bootcamp. It's going to be part of the items that we're going to send to you. But for Checkpoint itself, you do not need anything special because the evaluation license is built into the actual image. I'm going to go ahead and use the key pairs that I created for it. I do want an elastic IP, so that's true. I'm going to leave my root volume at 100 gigs. I'm not going to have that many logs because it's just a lab. Encryption is recommended as a best practice, so you want it there. I normally change the enable instance connect to true because I want the option to be able to connect to these systems via the portal, in addition to just via an SSH system. This CloudFormation will create permissions for your manager. You only need read permissions. I like to automatically get read-write permissions because there might be some fancy things that I want my manager to be able to do automatically for me later on. But if you have a lockdown system, if you do not want your manager to be able to do some things in the cloud that you don't, that you will rather do manually or via Terraform orchestrator, you can just do regular read permissions and everything in this exercise will work fine. You can also use pre-existing IAM roles instead of having us automatically create a role for the manager for you. The manager needs this role because the manager will be connecting to AWS, as we will see in a second. As I mentioned, I am selecting BYOL. BYOL is the one that has the free license for Checkpoint products. Do not select the pay-as-you-go when you're working on lab environments. Only the very first pay-as-you-go instance on any account has an EVA license to it. that would mean that you will basically use up your email license on the manager if that's what you deployed first. Maybe somebody was playing with checkpoints 2 weeks ago and they used up that license. So when you deploy pay-as-you-go, you're going to be paying from minute number 1. So always use BYOL for labs and tests because you get the 15-day free license with that included. The admin shell that's here by default is Clish, which is the normal license that you see when you log in into an appliance. I usually switch it to Bash because I want to be able to get to the expert prompt directly when I log into the system via SSH or via the serial console. You do not have to do Bash, but if you want to go directly into the expert, you can change the shell here. And then when you SSH or serial console into it, you will be automatically in expert mode. That may not always be a best practice if you have multiple administrators with different access rights. If that is the case, you want the shell to be Clish because you want your administrators to log into Clish first and then go to expert only if they have an expert password. The next thing is going to be a password hash. It is optional. You do not have to put a password hash in here. However, I like putting a password hash because that allows several things. One of them, it allows me to log in into the serial console. The password that we have here is not needed to SSH because if you remember, we're going to be SSHing into AWS using our private keys. But there are things that do require a password. For example, if you connect via the web, you will need passwords. If you connect via the serial console in AWS, you will need that password. So I normally do recommend that you create a password. There is a utility to create the password. The utility is in the guide. So actually, there were some people that have that joined in sort of recently. So I'm going to put in the link to that guide one more time, because one of the things the guide includes is a link to where you can create your own password hashes that will be compliant or compatible with the checkpoint environment. Not every password hash will work. So I strongly recommend that you use the hashing engine that is in the lab guide when you create your hash, because that one is guaranteed to work with the checkpoint environment. I'm going to go ahead and put the hash that I generated for my system in there. I am going to leave the host name the same. This is my primary manager. You can create secondary managers in the cloud. So you can have your primary managed on-prem and your secondary up in the cloud. You can have your primary in the cloud on the East region and your backup in the cloud on the West region, or your primary can be in the North American continent and the backup can be Europe. It doesn't matter. But this will allow me to do either a primary or a standby. Since we're deploying a primary today, this is going to be true. SIG key is my one-time password. This has to match between my manager and my cluster members or my gateways or my scale set members, whichever. So you can put any 12-string character here. This says at least 8. I believe that the filter may actually be for 12. So if you put 8, you might get an error. I always put 12 characters. For labs and demos, I use A, B, C, D, E, 1, 2, 3, 4, 5, 6, 7, 8. Or you can do A, B, C, D, 1 through 9. Or you can do 1 through 9 and then add A, B, C, D, E. It doesn't really matter. Or you can do a password generator or generate something on your own. This password cannot have special characters. They have to be alphanumeric. They have to be letters or they have to be numbers. But remember, this is going to be used as a one-time. You're going to be using this just one time when you first connect, and then the manager is going to exchange certificates with the gateways, and everything is going to be encrypted and authenticated using those certificates after that. So again, the SIG key is only for the first time environment. Allow uploads and downloads. I usually make that true because that allows the management in the cloud or the gateways in the cloud to reach out and automatically download their licenses. Administrator addresses, that is the same as the GUI restrictions in the manager. I'm going to let it open for anybody in here. For gateways to manage, I'm going to restrict that to gateways in the AWS environment, but you can restrict those gateways any way that you want to. This says locally managed because my manager is going to be in AWS. If your manager is on-prem, then you're going to change that from locally to managing over the internet. After I left everything else in default, you can change those if you wanted to. I just then do my acknowledgements and click the create button. The create button is going to start rolling out my CloudFormation template. I can refresh my CloudFormation template and see how the progress goes. When it is finished, this create in progress will switch to successfully created or create complete. But in this case, I'm just following along by periodically pressing my refresh. Now, one thing, I've accelerated this on the video. This is going to take several minutes. It's going to take about 4 minutes for the manager to come in and allow you to connect to it via SSH. It's going to take longer than that before it allows you to connect via Smart Console. But I have some tricks to let you know how soon you can connect. So I'm going to keep refreshing here, but one of those refreshes is going to show that the instances were deployed. You're going to be able to see it on those events. And that means I'm going to be able to see my instance here. And I'm going to wait until it says running. And actually, let me back just a few steps so you can see that again. See, this says running and status check says 2 of 2 passed. That means that I can SSH into this instance. So I'm going to go ahead and SSH into it. I'm going to look at my public IP address, which is why I've scrolled over. This is my public IP address. I'm going to copy that address. I'm going to paste it on my SSH system. Somebody asked me just now, are there any restrictions for type? There are no restrictions for type in AWS other than the fact that we QA certain types. We normally use M types for managers. We normally use C types for gateways. We use M types for managements because they have more memory than your normal instances. The managers love a lot of memory. So the more memory you can assign to those types, the better your manager is going to run. And that is the reason we use the M for deploying managers. We use the C for the gateways because those are the ones that have the most powerful compute engines usually. The gateways use CPU for inspection. So they don't care that much about memory. They want compute power. So compute power is usually what we use for the checkpoints, gateways. You do not need to use them. The compute ones are the ones that we QA. Those are the ones that are probably going to give you the most bang from the buck. But you can run gateways with M types and you can run managers with C types. Just make sure that if you're in a manager, you have at least 8 gigs of RAM because again, managers kind of love that extra in memory room. Okay, so I'm going to copy my public address from the manager. I'm going to fire up Mova Extern, which is my buddy client, and I'm going to put that IP there. I'm going to say this is an SSA session, and I am going to specify my username, which is admin. That is the default username for every deployment that we have. And I'm going to go to advanced settings and get a copy of my key, which is on my downloads folder. So I'm going to move to that and get it from there. You do not need to use Mova Extern. PuTTY would work. There's all sorts of different SSH clients that you can use. I just happen to like Mova Extern because I can troubleshoot multiple things at the same time. I'm going to be able to log in. The first thing that I usually do is at top to make sure I see things running in there. That looks okay. I also ping the internet. I ping the internet because the CloudFormation template will verify that the manager can connect to the internet. If the manager cannot connect to the internet, it is going to roll back your deployment. So one of the things that I do is I make sure that I look at the routing table before I deploy. And after I deploy, I connect to it and do a quick ping to anything out on the internet, doesn't matter where it is. By doing that, I verify that I have the internet connectivity that I need. If I don't, then I know that this is going to start rolling back after a few minutes. So I usually troubleshoot what my connectivity issue happens to be before that happens. The next thing that I'm going to look at in here is I think I normally want to see if the wizard has finished configuring my management server. So I am going to stop this in a second after I type the commands, and I'm going to tell you what is it that I'm going to be doing. Okay, so let me stop that right there. If you notice, I went to var log, that is where the logs are stored, and I look for FTW. And I found the FTW install log. FTW stands for first time wizard. The first time wizard is the process that runs configuring the manager, and making sure that it is a manager, opens up and loads everything. So I'm going to do a tail -F on that log. And that will show me how far along my configuration is. So as I can see, it's still creating. Once this wizard finishes and I'm ready to connect, it's going to say FTW complete. This is also moving a heck of a lot faster than it will be in your own environment. I just accelerated it, so we don't have to wait the 4 or 5 minutes that this takes. But that's what you're going to see at the end, that FTW complete that you see right there. That is what we want to see. Once we see that, we're almost ready to connect. I normally run an API status. That may tell me that some things are stopped or still starting. So this is not quite ready. Another way to see if this is ready for connecting is by looking at top. You notice it's Java sessions. Those are the management server tasks starting up. And you're going to notice that that's going to be running at over 100%. So if I try to connect to this management server now, while everything is starting up, it's not going to let me. It say I cannot log in at this time, and it's going to give me an error. So I normally do some top or run the API status to see whether all my processes are up and running, or whether it's still loading stuff. So I waited a little bit. I did API status again, and now show me that everything is started here, including the API itself. So I normally can go ahead and connect via Smart Console at this point. I can also go and do a top and check in here. The Java should have disappeared from the top of the system. So now I should be able again to connect, because it means that all the big startups already happened. So I'm going to go ahead and I'm going to download my Smart Console. In my particular case, I already had it downloaded and installed. The lab, we recommended that you use R81. The printed lab guide says R80.40, but you really should use at least 81, because there's a couple of nice things that 81 brings, and we're gonna show some of those as well for you. I am going to put the IP of the manager here. That's the IP that we want, 18.235.9.94. And the password is going to be that hash. If you remember, we put that password hash on the CloudFormation template. That is the password that you're going to be using for this Smart Console session. So let's see. Yep, I'm going to go ahead and use my hash password. I was just verifying my public IP, and I'm going to say login. Since everything already started, I got my proceed, and I got my initializing services, which is what I want. If you don't get to that piece, 9 out of 10 times, the system is just starting. So it takes a little while for that to happen. Okay, so I can log in with my Smart Console. So I'm going to go to step 2 of this exercise, which is provisioning a web server instance from the marketplace. You do not have to deploy the same instance the lab recommends. And I'm going to show what that is in a second. I'm going to go into EC2, or I'm going to type EC2 up here. So it takes me to the same place. And what I want to do is I want to launch instances. So I'm going to click on launch instances. I'm going to move to the marketplace, just like I did for Checkpoint. The web server that I deploy is usually the LAMP version. You can deploy Nginx or whatever, or Ubuntu, whatever you want. I usually use LAMP by Bitnami because it doesn't ask me to register my name and address. And they have a free version of it. They do not, I don't believe that they require me to accept terms, but you may want to accept terms just in case. And notice that I use the T2 Micro because that is free for 30 days, I believe. After 30 days, it's going to be about 3 or 4 cents an hour. So it's a very basic load balancer. I mean, a very basic web server. I'm also going to actually type in the IP address on the marketplace, just because the lab suggested that I use 10.0.1.5. That is because it makes it easy. I know beforehand what my object IP is going to be. And it also wanted me to add a web server tag to it. You will see why later on. That's going to be something really nice that we can do with the controller. I get to pick my keys. So I'm going to pick, not that one. I want my key pair, which is the one that I want. I click the acknowledgement. I say launch instance. And that is going to go ahead and launch my web server in AWS. It's going to be loading it up in the private subnet. If you saw the lab diagram, that's where we deployed it. This does not have a public IP address. The only way we can get to this web server is going to be if we go through the checkpoints. So that is where we're going to be setting up on the following exercises. We're actually going to deploy the cluster members. You see them here already deployed because I didn't follow the exact order, but you will see we are going to be deploying those in the next exercise. I am just naming my web server, and making sure we can move on. And we are pretty close to the end. Our web server is running. Again, we do not have a public IP address. So exercise number 2 is finished. Okay. Again, we're skipping exercise number 3. Exercise number 3 is a lab version of our posture management solution. It will not work on regular outside AWS environments. So we're going to be talking about that after we finish all the exercises for this session. We are right now at the hour. So as I promised you guys at the beginning, I like to have a break after 1 hour so people have a chance to go to the restroom, get something to drink, stretch your legs. So we're going to take about 2 to 3 minutes, and then we're going to keep on rolling with exercise number 4. So while we let people do that, we're still going to be recording. So if there's any questions that you want to either put on the chat or maybe even on mute, you can ask those questions right now during the break. I will stay here and answer them. Otherwise, enjoy your few minutes break. Yes, somebody just commented that exercise number 3 is missing. It is missing because it will be on the guide, but even if you try to do it, it will not work. Exercise number 3 is an exercise to give you access to a posture management template that works with our in-house environment. We're not using our in-house environment, so exercise number 3 will not work for you. You can try to deploy, it's just not going to be, it's going to give you an error. That's why we are skipping exercise number 3, because we're doing this with a live AWS account. I will be showing you everything that you would be seeing if we had exercise number 3 at the end. After we do exercise number 5, we will go into the posture management piece. You will see what it looks like. You will see the type of things that it lets you see and connect to. So do not worry. It is going to, that exercise number 3 is going to be part of this presentation. You just won't be able to follow along or do it if you have the guide, because that guide exercise 3 will not work. Any other questions? Okay. I am going to mute myself for 1 minute and I will be right back. Again, to everybody, we are at our first break. We're going to be in the break for another minute and a half or so. And then we're going to resume with exercise number 4. We're not doing exercise number 3 because it will not work for the environment that we are using today. Welcome back. Hopefully everybody is going to be back already. If not, you probably won't miss anything. Remember, we're recording everything. So even if you get back a little bit late, you'll be able to catch up on the recording later. We are going to do exercise number 4 now. So I'm going to go ahead and do the open hyperlink. And in this particular exercise, we're going to be deploying the Checkpoint CloudGuard clusters. Just like we did for the management server, before we go to the CloudFormation, we really want to go to the home page first and accept the terms for the gateway. Once we do that, we can come back and either click on that link on the lab or go to support.checkpoint.com and look for CloudFormation, go to the CloudFormation templates, and run the deployment. Now, I already accepted the terms separately for the cluster. If you have not, follow the same exercise that we did for the management server. And actually, I'm going to go ahead and just go there right now. You just go to launch instances, and you go to marketplace, and you do Checkpoint. You can also do CloudGuard, by the way, when you look. And in this case, we're not doing the management. The cluster is going to be based on the regular network security, threat prevention, and sandblast. BYOL, that's the piece that you want. So you want to select to accept terms. You want to select that image. That is going to bring you here. You're going to click in here, view details, and you're going to say continue to subscribe. And then you're going to get that big orange button that says accept terms. That's what you want to do. I already accepted the terms, so I cannot do it from here. But remember, you want to do that before you deploy using CloudFormation, or CloudFormation will basically not work. You will deploy and then stop and tell you cannot finish because you have not accepted the terms. So let's move back to our recording. After you've accepted the terms, then we can come here and we can go to security cluster, which is what we're deploying today. We're deploying a cluster into an existing VPC. We're deploying that cluster with version R81. Sorry, that went a little bit too far. Since we're doing R81, I want to use this button on top. We also have a Terraform link. So if you want to deploy a cluster using Terraform, you do not need to use the CloudFormation button. You could deploy download the CloudFormation template as well if you want to change it or use it as part of a larger deployment. Or you can download the Terraform link. It does exactly the same thing and customize it however you will. For the exercise, we're going to be using the CloudFormation stack, and we're going to go ahead and launch it by pressing that button that you see here. Actually, sorry, the deploys into an existing VPC, this button. The other one will create a VPC for you. Okay, so we give our stack a name. If you leave the default, it is fine the very first time. If you do this more than once and you already have something with that default name, you'll get an error. So I usually, the first thing that I like to do is I just like to change the name of my stack, just in case I've already run it before, it will not conflict. The next thing I'm going to do is I'm going to choose the VPC network. Oh, by the way, only dashes are allowed. I put some underscores there, so I made sure that that fixed. I'm going to select AWS training. I'm going to select my public subnet for my public, my private subnet for my private. If you remember, the gateway is going to have two interfaces, one public and one private. So it's going to ask us for these two. Internal route table is optional. That is if we want to configure some of the routing through here. I'm not going to do it. This is the name of the gateway in the AWS portal. So I just want to put some name that lets me know this is a checkpoint, and specifically a checkpoint cluster, which is what I'm deploying. The next thing we're going to do is we're going to pick up an instance size. I'm going to switch that to C large, which is just 2 CPUs. I don't need extra large for the lab. The gateways don't need that much memory. You can have gateways with just 2 virtual CPUs without any problem. I know that some other vendors force you to use 4 virtual CPUs as their smallest. We have no problem with you running gateways with 2 virtual CPUs. They work perfectly okay. I'm going to go ahead and select my key pairs. Again, remember, we're using the C's because of compute. We want something that has a lot of computing power, but you're not obligated to use it. I am asking for elastic IPs for these systems. These gateways don't need to have elastic IPs because the manager is on the cloud and is going to be pushing policy to their private addresses. I just, again, like to put public IPs on my gateway so I have some way to get to them in an emergency. If you have a Bastion host, you don't need this. You can just connect to the Bastion host and then connect internally to the systems. If you do put elastic IPs, remember to have a rule that makes sure that nobody can come in and connect to your managements or gateways unless whomever you specify. You do not need a lot of storage space, so we're going to leave that as is. We're going to leave the default encryption. We are picking, remember, R81, bring your own license. We are, or I like to use Bean Bash. Again, if you guys remember, this takes me directly to the expert prompt when I connect via SSH or Serial Console. I just like that shortcut. But if you have multiple administrators and not everyone has access to the expert prompt, leave Clish in here, which is the default shell. And that means anybody that SSHs will be in the Clish and can only access expert if they have the password for expert. My password, I think I left my password hash blank in here. You can create it. You can create it and put it in there. My SIG key has to match the one-time password I put in the manager, which for this lab, I think I use ABCD 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it's just a one-time throwaway. Everything else in here is going to be optional. I believe I'm double checking. For some reason, I decided to change. I switched that to, no, I know what I did. This gateway is the host name. And I just made it match the AWS portal name. So, I was going to cut and paste. I obviously changed my mind. Okay, I left everything else default. I put in my check marks and I'm going to do create stack. And then the CloudFormation template is going to run. This is going to be very similar to the manager. It's going to take a few minutes. It's going to take less time than the manager. The gateway should be operational and ready to go in about 4 minutes. But I can follow along by clicking on refresh in here until I see my cluster say create complete. I can also see the instances appear before it's fully complete. And the moment I see them here, I can switch over to EC2 and actually start SSHing to them or connecting via the Serial Console. It will allow me once they're up, even if they're not fully configured. And I just saw member instance create complete. So I know even though the clusters hasn't finished, I can start already connecting to these via SSH or via the Serial Console. That's what I was looking for. That member A instance create complete, member B instance create complete. So if I switch here, I'm going to see them here. You saw them running right there. They're still initializing. So remember, that means that they haven't booted all the way up. When I see the 2 checks passed, then it's usually safe for me to connect to them, because even if they're on the wizard, I can connect to them without harming them. And notice that I'm connecting to these a little different than I connected to the manager. The only reason I'm connected to them differently is so you can see the option. I just selected the cluster member that I want to connect to, and I'm going to go ahead and select it right now. I'm going to click on member A, I believe, and I just did that. And notice I am going to press this connect button that's here. By pressing the connect button, I'm going to get several options to connect. One of those options is the serial console. I like to use the serial console when the system is booting up, because the SSH will not show you the boot up commands. The serial console will. So if this system is still booting up, is still not fully configured, I can go into serial console and I can see the boot process as it goes. I can see the, every single part there, and I just select serial console and say connect. And I come into this window, I click and hit return, and I will get either the output of booting, or in this case, it is fully up. I just got my login and password. You need to have defined a hash password to be able to put a password here. Otherwise, I would need to connect via SSH. So that this is also one of the reasons I tell people, go ahead and put in a hash, because otherwise you won't be able to connect via the serial console. And it's sometimes for debugging or troubleshooting, it's kind of nice having that serial console capability. So I am going to go ahead and go into Smart Console, because we now have a cluster that's deployed, and the cluster needs to be defined on our manager. So I'm going to go ahead and do that. I'm going to connect to our manager. I'm just checking, making sure I have the right IP. It's already there. So I'm going to go ahead and put my password. Remember that password was the hash that we put in during the CloudFormation when we deploy the manager. You can change that password from the command line via SSH before you ever connect to it, if you ever need to, by the way. All you need to do is go to Clish and say, set user admin password, return, and it will allow you to do that. Okay, so here's my Smart Console. I'm going to add the two members. I'm going to add cluster member A first, and I'm also going to add the cluster IP first. So if you notice, I hit the networking tab and I scroll down. I scroll down because I want the secondary private IPs. The clusters are going to have two sets of IPs. They're going to have the IPs associated with the interfaces themselves, and that is going to be a public and a private IP, and you can see them sort of up here. And they're going to have a secondary set of IPs, or the active members, the only ones going to have them. So the active member can be A or B, but you can connect to both of them and look for this secondary private IP address. These are your cluster IPs. They come in secondaries. So I'm going to grab that cluster VIP IP to use or create my cluster member. So that's what I was looking for, that 10.0.0.9.4, which is my secondary private IP. The ones up here are these ones are the ones that are assigned to the interface directly. So if we go to cluster member is not going to have secondary IPs. It's only going to have the regular IPs that come to the interfaces. So I won't be able to see a secondary IP associated with this one. So let me go over to Smart Console. For some reason, I was looking for something else, but come on. I'm going to jump a little bit to it. Oh, okay. I went back to cluster member A. Again, these are the interface ones. These are the cluster. So I'm going to copy that 10.0.0.9.4 because that's going to be my cluster VIP. So let's see. Oh, one thing that I like to do sometimes is I like to connect to the cluster members just to see whether the IPs were correctly set up. Remember, if I do it this way, I need my private key. So I'm going to use my private key for that. And this is going to let me open an SSH session. And then I do the same thing I usually did with the manager. I may want to ping something on the outside just to make sure I have full connectivity. In this case, it doesn't really matter because I connected via SSH, but I can also see and make sure that my IP addresses match the IP addresses that I see on my portal, which should. Okay, so I'm going to go ahead and create a cluster. And let me jump to that. Oops. I go to objects, I go to object types, and I go to gateways and clusters. So network object, gateways and servers, clusters, new cluster. You can use the wizard mode or the classic mode. It doesn't matter. Either one is fine. I'm going to name my cluster. And again, the name can match the cluster name in here, or you can just call it anything else that you want. They're just names. They will not affect anything else on the system. So I'm going to give it a name. And then I'm going to use that cluster VIP in here. And the cluster VIP was that secondary IP address associated with ETH0. So apparently I forgot where it was already. So I'm going to scroll down. Cluster member A, there's my secondaries. And that 10.0.0, that's my public side. That's the one that I want. So I'm going to go ahead and copy it. And I'm going to put it here. And I'm going to go to the next. And now I'm going to add my cluster members. To add the cluster members, I basically just go to the cluster member properties. I say add new cluster member. This is going to be my member A. And I think I'm going to use the exact same nomenclature here. So I just came in and copied it. And remember, that's the IP that I want this time, because that's the IP associated with the interface itself. So I'm going to go ahead and give this a name. And obviously, I already forgot what I just read 2 seconds ago because that's different. I think I'm going to go back and make sure. And I just noticed. So there's a dash there, and there's a dash there. There we go. And the IP address is the IP address for ETH0 that I saw. I'm going to put my one-time password. In my case, for the lab was ABCD 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to confirm, and I'm going to hit my initialize. And the manager should reach out and exchange certificates with the gateway. So I'm going to go ahead and add cluster member number 2. I'm going to check out the IP. So I'm going back to the portal. I'm going to click on CP cluster member B. I'm going to change the tab to networking. Actually, for this one, I don't have to, but I usually like to. And that's the one that I want. That 10.0.0. That's my public subnet. So that is the IP that I want for cluster member 2. And if you saw just now, I scrolled down. There were no secondary IPs because the VIP is currently attached to cluster member number 1. I just use my activation key, ABCD 1, 2, 3, 4, 5, 6, 7, 8, 9. I repeat it, and I click initialize. And that's going to form the cluster. Trust established. Now, at this point, I actually finish. We're going to go back in, but there was a funny thing that was happening before, and you can avoid it. If you do finish right after joining both the members and then double clicking on the cluster and going back in for anything else that you want to turn on, right? Or maybe you want to turn off IPSEC VPN or turn some of the other blades or whatever. But doing a finish right after adding both members or coming back in will get around that little bit that we had a while back ago, which may or may not be taken care of already. So I'm going to go into network management. And I'm going to get interfaces with topology. So it's going to connect to both systems. And it's going to import all the IP configuration information. And I'm going to basically add a couple of things here. I'm going to add the VIPs. So I'm going to go to ETH0. And you can either double click there or highlight and click edit. And in here, I'm going to switch this private to cluster. These are my 2 members, but I'm going to add now the cluster VIP. So I'm going to come in here and it says cluster. And this is going to match the cluster VIP for a member, for the ETH0 side on member 1. So I'm going to go to member number A. That's right. And I'm going to do networking. And I'm going to scroll down to the secondary IPs. And again, these are the ones I want to use. That's the VIP for ETH0. That's the VIP for ETH1. So I'm going to come back and get that one in a second. So ETH0, there's my VIP. 24 is my subnet mask for this. And I'm going to say, okay. And now I'm going to go ahead and edit ETH1. And I'm going to switch this to cluster plus sync, because remember, we want stateful inspection. So there's a cluster sync port. I normally use the internal port for that. And it also has a cluster IP. So I'm going to go ahead and grab the cluster for ETH1, which is that second IP that's here. The one on top is for ETH0. This one's for ETH1. And you can see that it matches 10.0.1, 10.0.1. It matches the same subnet as the member IPs themselves. So I'm going to say, okay. And we now have our cluster configured with our sync port, which is going to be our internal port. And we can say, okay, in here, or we can go back to general properties and turn things on or off if we want to. That's not a problem. So I am going to now try to push a policy. I'm going to go to security policies. For the lab, I'm just going to do something very, very basic. I'm just going to grab the cleanup rule and just switch it from drop to allow. Again, this is a lab environment. You may want to do something a little bit more restrictive if your lab environment has anything of importance there. I just hit publish to save the change. And now I'm going to go ahead and push it into my cluster. There's a button up there that says install policy. I think it's a little bit off the frame. I disable threat inspection because the very first push, the very first time you push policy, you usually should just push access management. So I said, okay, I went in and looked for details, and now I'm just going to follow on with the installation. R81 has policy install acceleration on it. It's not as dramatic in the cloud as it is on-prem or on physical gateways, but it's still a little faster than it normally goes. So that's one of the reasons I wanted to use R81 instead of R80 something for this. So it already started, put it on cluster member number 1, cluster 2. So we have our cluster already with the policy. And if we go back to gateway servers, this is going to change to green. It takes a few minutes, but usually if you push policy and it pushed correctly, you will see that go to green in like a minute or two. The license status will always show a warning if you're using the EVA license. Do not worry about that. It's just warning you that in 15 days, your EVA license is gonna croak. Okay, so that is exercise number 4. And we're going to do exercise 4B. The reason I have 4 and 4B instead of just 4 is because I thought I was ready and finished with exercise number 4. And then I realized that there was more stuff to do. So I am double checking I push policy. So one of the things that I do after I push policy is I SSH or console into the members. And I want to make sure I didn't lock myself out. So I just do a ping out to the internet. If you lock yourself out from SSH, you can still connect to it via the serial console. That's one of the reasons I love the serial console. The serial console is a serial connection and completely bypasses the firewall policy. The only way you can get to the serial console is through the AWS portal if you have access rights to these instances. You can do a lot more than just connect via serial. You can destroy them if you have that right. But again, it's just a matter of selecting them, clicking serial console, clicking connect, clicking on the screen and hitting return. And then I just want to make sure that I can log in and I can go out into the internet and I have, and stuff is loaded. I can run CPHA probe to make sure that the cluster is up and running. I can do FWStat to make sure that the firewall policy loaded. So just some basic checks that I can do from the serial console to make sure that everything is okay. Okay, so moving on, and one of these went green. Don't worry about that again. If their policy installed, these two will go green eventually. It's not a biggie. If you are doubting it, highlight it, go to the monitor, and you're going to see that if all three of these are green, that little red ball is going to go green in a few minutes. So that's another way to make sure that we're doing okay. Again, if you think that there's an issue, in this case, I just went to test SIC. It's communicating. Everything is fine. It's just taking a little bit longer for that to go green. It's not a big deal. Okay, so we are going to create some policies and some NAT policies. So we just did the single rule at first, just to make sure that we could push policy. But now we're going to make some rules for our lab. So the lab wants us to create a couple of hosts. One of those hosts is the web server. I think it's going to create for, yep. And if you remember, the web server have the 10.0.1.5 IP. But I'm going to double check just to make sure. I'm going to go in there. I'm going to click networking. I don't actually have to. It's right there on the main page. And I'm going to put that IP on my web server object. And I'm going to go to NAT. And I'm going to say automatically NAT hide behind the firewall. Remember, this is hidden. It's fully internal. So the only way you can actually talk to the internet is if it has that NAT associated with it. I am also going to do another host. And this host is going to be for the external VIP of the cluster. I am going, so I'm going to call it cluster ETH0 VIP, I think I'm going to call it. But that's basically what I'm doing. It's going to be ETH0, and I'm still thinking what I'm going to call this. It's the cluster ETH0 virtual IP. That's what I'm going to put in there. Once I eventually finish naming it. And I'm going to go back to my portal. I want to make sure that I put VIP in there so I remember what this object is. I'm going to go back to my portal, and I'm going to go to cluster member A, and I'm going to go to networking, and I'm going to scroll down because it's the cluster VIP that I want to use. Oh, by the way, between the time I deployed the first cluster and the time I finished this lab, I had already deleted the other cluster, so I recreated one. That's why you see that IP is a little bit different, but I just wanted to create those two member objects. So now that I created them, I'm going to put them on separate policies. I don't want them included in the club rule, so I'm going to take them out of here, just remove them from this rule. And I'm going to create a couple of rules on top, and I'm going to use these objects. So the first rule I'm going to create is going to be to give access to the web server, I think. Oh, no, I selected the cluster member. And I am going to give access also to the web server. And these are from any, and I'm going to go ahead and choose the protocols. For the web server, I think I'm going to do HTTPS and HTTP. Yep. For the manager, I'm going to be doing it. I think I actually did SSH for all of them. So I'm going to do SSH for that one as well. Yep. And I'm going to do SSH for this one. And I am now going to switch the action to accept. And I'm going to turn login on. And now we have some specific rules that allow access to the web server via SSH and HTTP, and access to the cluster VIP via SSH and HTTP. Now, I'm going to do one more thing after I turn the login on, and that is I'm going to make a NAT rule. Because if you remember, our web server is fully internal. So what I'm going to do is I'm going to map a web command to the VIP to go through the checkpoint gateways and actually connect to that web server in the back end. And for that, I say anything coming from the internet that hits the VIP. And if you remember, I created that That's why I created that host with the cluster member VIP on it. So I'm going to go ahead and select it now. Anything on the internet that hits the VIP, by the way, that's a drawing thing. It's going to go away eventually. Don't worry about it. That hits it on HTTP. And I'm going to hit I'm going to put HTTP in here. There we go. I want to retain the original client IP, if that's what I want. And I'm going to redirect that traffic through my web server. So I'm going to put it here, web server. So now anything from the internet hits the cluster VIP. And I just redrawing anything from the internet hits the cluster VIP over HTTP. I want to keep the original client, but I want it to be redirected to the web server. And I tested this. This is what the guide tells you to do. This is missing one step. And I did not realize this until I pushed policy. So I think that this is going to get shown in here. I'm going to publish. I'm going to push policy. And then I'm going to try to connect to the web server using the VIP. And you're going to see what happens. And I'm going to show you what the missing step is. So details. Here we go. Pushing policy to the cluster member. Okay, done. So now I am going to try to connect via HTTP to the cluster VIP, and that should be redirected to my internal web server. So at some point, I'm going to close this. And oops, I didn't do the test. I came to fix it. Okay, so it wasn't working. I noticed it didn't work because the routing table doesn't have a way back to the internet. So the web server is actually on the internal side, and the internal side does not have a route back to the internet. So the way for the web server to be able to reply to that inbound address is it needs an IP that it knows how to get to. So what I did is I just, I'm going to do a NAT hide behind the internal VIP. I think I did do the test. I went in here to cluster member A. I copied the public IP. Yep. Which is this one. And now I'm going to try to do HTTP, and you're going to see it's going to fail. And hit return. And this should happen almost immediately. So the moment that I saw that it wasn't happening, I said, I went into my logs. So I'm going to switch over to Smart Console. I verified that I had the right public IP, and I do. So I'm going to go into my logs and see, am I getting to the checkpoints? And I'm looking for traffic over port 443, so actually over port 80. And that's it. That's my port 80 traffic right there. So I double click that, and that's my home IP. So I double click on one of those and verified that it is being accepted. It is coming in. It is being translated to 10015. So inbound, everything is working okay. So I figured, oh, the web server doesn't know how to reply to this back to the internet because it's seeing the original internet IP. So I am now going to go to the security policies once more, and I'm going to NAT my inbound behind the active cluster member. So we're going to do this, and we're going to go in here, and that translated source, I am going to actually put in the internal VIP in there. Now, you do not need to do natting when you're using a cluster. The only reason I'm doing natting is because I found out that the web server was not able to reply directly to the internet because there was no route to it. So the easiest fix is to just have it NAT behind the active BIP, right? But if your web servers are in different VPCs or they're in different subnets, you could have a route that says the route back to the internet is the ETH1 interface of my cluster member. And if you do that, you do not need to NAT because you have a route already in AWS that is telling your systems how to reply back to the outside. So this is my cluster VIP. I create an object for it. I put in here. This should be a hide. So I switch this to hide. So I'm now hiding behind that internal cluster VIP. And I'm going to save, publish, and I'm going to push this. And I'm going to try connecting via HTTP again. I want to look at details, make sure that it installs correctly. That looks up, it's in. So I should now be able to go back to my original web page, the one that timed out before, and I should get a connection this time. So here we go, web. I just hit a refresh, and boom, I just hit the Bitnami LAMP web server internally. And that is the end of this exercise number 4. So we now have created the VPC and the subnets. We have deployed the manager. We have deployed the cluster member. And we have created rules that we push to the cluster member and that remap inbound web access to the web server. And we have seen that that succeeds. So we're going to go into the last exercise, and then we're going to go into posture management a bit. So let me go ahead and double click in here and do open hyperlink. And what this exercise is going to be is enabling the CloudGuard controller. The CloudGuard controller is a fancy name, and I don't know who came up with this name. It is the ability that your management server and your firewall gateways have of connecting to the cloud. We have a connection that we do over TLS, over HTTPS, to the API gateways in AWS or Azure or Google or whichever our systems are. And that allows our manager to talk to the cloud environment. We do this for many reasons. This lets us fully provision scale sets because the manager can see the scale sets. You can see the scale sets come up. You can see the scale sets gateways be deleted, and it can match those activities on Smart Console by adding and deleting objects for us automatically. So provisioning is one of the reasons that we do this. The other reason we do this connection is because sometimes we want to just drag and drop objects in the cloud into our security policies, or we want to use tags. We can tag systems on the cloud. Like, for example, we can tag database servers as database servers. We can tag web servers as web servers. And then if we look for something that will look for these tags, we can create logical groupings in Azure and in AWS and allow everything as a group to have access to something. So the example I normally give is if I tag all my database servers in AWS with a tag that says database server, and all my database servers in Azure with a tag that says database server, I can create a rule that says all my database servers in Azure and in AWS can talk SQL to my application servers. And then I can put everything that is tagged as an application server in AWS or tag as an application server in Azure. What this means, if I'm deploying servers or taking servers out of commission, all I need to make sure is that they have the right tag and they will be able to have the access that they need. So I can deploy via orchestration 300 database servers. I can use the orchestration script, tag them as database servers. Those 300 database servers will immediately have access to any rule that says anything that's tagged in the cloud as a database server can do this. It takes the manager about 30 seconds to see them. So it usually takes longer for an orchestrator to deploy them than for the manager to see them after they come up. So within 30 seconds, the manager will see those objects. And if they belong to a rule, the rule will be enforced immediately. There's no need to push policy or publish any changes. It will happen automatically. So exercise number 5 is how to configure that connection into the cloud. So step number 1 says to SSH or serial into the management server and type CloudGuard on. we do not need to do that on R81 anymore, which is one of the reasons that I wanted to use R81. I'm going to go ahead and do it just so you guys see what's going to happen. I'm going to go to the serial console and I'm going to log in and I'm going to type CloudGuard on, which is what the lab tells us to do. But that was only for R80 and below. R81 does it by default. There's no CloudGuard on service in here, and that's what we're getting a command log found. So that means I can go here and immediately create a connection to AWS. So I'm going to create an object. I'm going to go import data center, new data center. I selected AWS. I'm going to give it a name. The reason we give these a name is because we can have multiple connections to AWS. We need one connection per account. So if we have multiple accounts in multiple regions, we may need multiple connections from our management server. So the management server can see all the AWS accounts that it needs to manage. I normally give these connections names. So I'm calling this one AWS Data Center 1. But if you have a production account and a non-production account, this connection could very well be AWS non-production or AWS production. Give it any name that makes you remember what that connection is. The next thing I'm going to do is I'm going to choose a set of credentials. If your management server was created in the cloud, you remember that I said create read-write access rights for this. And I told you it's okay if it's only read-based. That creates a role for me. And the management server knows how to find that role. So I can either create access keys for my manager. I normally call, I create it as a user CP manager. I create an access key. I create a secret key, and I put them in here. But if I created my manager inside of the cloud, I can use the region, which is a lot faster. This is usually the access and secret keys are if my manager is outside of AWS, then I can enter those credentials and it can log in. But again, if it's inside, I'm just going to say, hey, I know there's a role for it. I know how to find it if I use the built-in one. All I have to do is tell it what region it is. It's on US East 1. I'm going to say test connection. Boom, I can connect to AWS. So I'm going to say, okay, I'm going to publish the changes. And after I publish the changes, it's going to open a window into that data center. And you're going to see within 30 seconds, actually faster because the first time you just goes and grabs stuff. I'm going to see everything in the cloud that our system can see. And that includes VPCs, it includes subnets, it includes instances, it includes load balancers, it includes security groups, it includes tags. All these things I can see. And from here, I can do drag and drops into source or destinations in my security rules. And if you notice, we collect every single IP for every instance. So that means if something is tagged, every single IP of something that is tagged is going to be collected. Now, that was step number one. Now my manager knows how to connect to AWS, and I saw that I can actually see things in AWS. Now I want my cluster to be able to know what's in AWS as well. So we need some way for the manager to tell the gateways, this is what I want you to do. These are the objects that I want you to allow or block out. We use identity awareness for that. We use identity awareness because having multiple thousands or tens of thousands of objects in the cloud is like having Active Directory objects with tens and tens of thousands of objects. And we already have a mechanism that allows the manager to enforce Active Directory for access to certain things. So we're going to use the same service for the cloud objects. So we are going to enable identity awareness. So that's what we're doing here. We're going to go to Smart Console. We're going to go into our cluster because our management can already connect. So I'm going to go ahead and the first thing is it's telling me to create a local host object. So I'm going to do that. And that's, of course, going to have the regular local host 127.0.0.1. And I'm going to say, OK. I don't want it there. Sorry, I was just using that as a shortcut. So I'm going to go to gateways and servers, and I'm going to go to my cluster. Again, it's still showing as red, not a biggie. I am going to enable identity awareness because I want the identity awareness to show up here in this menu. So I'm going to click in here. I'm going to get the wizard. I don't want to connect to an Active Directory at this point. I'm going to connect to terminal temporarily. I'm going to say I do not wish to configure Active Directory. And I'm going to say finish. And boom, now my identity awareness is here. I'm going to click on it. I'm going to uncheck terminal servers. Again, that's not what I wanted. I want that identity web API. I go into settings. I click on this little plus sign. I click on local host. And what this is doing is it's telling me that the local host, the checkpoint clusters are an authorized client to get object information, whether it's Active Directory or whether it's cloud objects from my manager. So that's what I'm doing by going through these steps. I say, okay. I close this window. You can say yes to that's just standard. I know that I have multiple objects with IPs, but now the checkpoint cluster, after I publish and push policy, will be able to retrieve or make enforcement of decisions based on objects in the cloud, which is what I wanted. I wanted some way of letting my gateways know. You can do this on gateways in the cloud, but you can also do it on gateways in different clouds and on-prem. So you can enforce AWS tags on gateways that are on-prem or on gateways that are in Azure. Or you can have tags in Azure and tags in AWS enforced in both clouds. All you need to do, if you want your gateway to be able to enforce based on cloud objects, any cloud object for any cloud that we're connecting to, is enabling that identity awareness and then pushing the policy into that gateway. If you try to do a policy that has cloud objects and your gateway doesn't have identity awareness turned on, you're going to get an error when you try to push a policy to the gateway that has those cloud objects. But again, I normally turn it on for both the gateways in the cloud as well as the gateways on-prem, because I want both of them to be able to use cloud sources and destinations as part of the rule bases that they're enforcing. So I have now successfully finished exercise number 5. And now we come here. Exercise number 5 is sort of like the end of deploying a cluster in AWS. We created a VPC. We created subnets. We created the management server. We created the web server. We created a cluster. And we connected that management server to the controller, which made it allowed to connect to AWS. And we turned on identity awareness on the gateways, which means that now the gateways can enforce policy based on those tags. Now I'm going to talk a little bit about posture management. The reason posture management is important is because if we are making rules in AWS that use tags, and everything that is tagged as a database server can automatically be able to talk SQL with something that is tagged as an application server, then it's very, very important that we control who is changing the tags, who is adding tags, and who is deleting tags, because somebody can go in and mess up with our tags, which will mess up with our policies. Another thing that we want to be able to do is, once I deploy a cluster or an auto-scaling group or a single gateway into AWS, I want to redirect traffic through that gateway. We do that using routing tables. Same thing happens. Somebody on the inside that knows how your architecture works can try to reach out, modify a routing table, and say, for this particular connection to this particular host, the next hop is not the checkpoint firewalls. The next hop is the host itself. And all of a sudden, I'm connected to that host, and that traffic is bypassing my firewalls completely. So we want something that's looking at the routing tables and is looking at the access control and makes sure that we're not bypassing our checkpoint inspection. We make sure that the tags are not being abused. Now, we could do it ourselves 7x24, but I'd rather be sleeping sometimes. So I want something that does that auditing for me. And that is what the CloudGuard posture management does. This is a SaaS system. So it's in the cloud. You connect to it via a web browser, like I did. Once you log in, you can look at a particular dashboard. I created a dashboard for my test AWS account, the one that we did for this lab exercise. And everything you see here is information from this AWS account only. I can have multiple AWS accounts, so I can click in here and I can see multiple AWS accounts and the inventories associated with it. Eventually, still collecting data, but I don't want to see Azure right now. I don't want to see a little bit of everything. I don't want to see the multiple AWS. All I want to do is my test dashboard specific, and we may still have some issues with AWS and in US East 1. But visibility into the cloud, visibility into the cloud is what I'm looking for. And the dashboard gives me the first thing. Everything in here is configurable. I can move these around. I can filter them in any way that I want by going here into settings and saying, okay, I want only AWS. I want only AWS from the test AWS account. I want only to see high and critical, but maybe I want to see medium alarms as well. So I go in here and I check on medium, and now I'm seeing medium as well. Again, everything is configurable in here, so you can have that dashboard show you whatever is important for you to see. Everything here is also clickable. So it's saying I have a high severity alert on cluster member A, which I just created. I actually have 58 of them. I can click in here and immediately go to the alerts window for this cluster member A. So if you see, I switched over to events, and I switched over to high severity, and cluster member A is what I'm looking at. So it's showing me everything in here for that. Something else that the system can do is tell you how easy it is to access or how open your cloud environment is. And that is what this other window that I had here open does. And I'm going to show you what this does. This is called Configuration Explorer, and this is seeing my lab environment today. Everything that's external is every network on the outside that has access to my environment. Everything that is in this DMC column is everything in my environment that is reachable by the entire internet. And as you can see, my checkpoint manager is reachable by the entire internet, and my cluster members are reachable by the entire internet. I also have something in here. I got my web server, which is private. It is under implicitly private because it is not directly reachable from the outside, but it is reachable through my checkpoint clusters. The reason we do this is because I can very quickly see if I have specific networks outside that are connecting or have the capability to connect to my cloud, and we can see specifically what is it that they're connecting to. Everything here is coming in either to the manager or to the checkpoint clusters first, which is what I want. Then from the manager and from the clusters, they can access things inside. So I normally would see this and go like, wait a minute, I want a manager to be able to connect to the checkpoints, but I don't want my manager to connect to the web server and things like that. So I can go in and change those access rules. Same thing in here. If somebody changes my security groups and gives the web server direct access to the outside, I will see a line that bypasses the checkpoint clusters and goes directly to the web server. And I would see, oh, wait a minute, somebody's trying to bypass my cluster members. You can zoom in into any of these. So I can click on Checkpoint Manager, and we can immediately see the ports that are open for the Checkpoint Manager from outside. So I have inbound connectivity on ports 257, which is the checkpoint logs port, by the way, and the TCP 443, which is the web UI. I can see also that all ports are open between my manager and my checkpoint cluster members. And I can see that the checkpoint has specific ports open to the web server. So my manager can right now do an SSH or go in over port 80 to my web server. So now I know I can go in and change this. This is what we called the asset view where I am right now, but I can switch this to a security group view. If I do that, I actually see the security groups that are managing that access. This is the security group that manages access to the cluster. This is the security group that manages access to the manager. This is the security group that manages access to the web server. So in here, I can see exactly which security group I need to go to make changes on this policy. So I can sort of click in here, and that will switch me over to the security groups. And from here, if I wanted to, well, actually, I click something. I can go into security groups, and in here, I can go to that specific security group. I think it's this one. And I can see what ports I have open to the inside, and what systems I can hit. Outbound services are open to everything, so I probably want to close some of those. And I can do it from here, or I can do it directly from the portal. Another thing that I wanted to show in here is the log analysis. We talked about log analysis being, actually, I'm going to stop here because we are at the hour again. So I'm going to stop for a few minutes, about 3 or 4 minutes, and then we'll continue with this piece. And I'm also going to show you how to create rules with tags in a second. So again, feel free to get up, stretch your legs, any bio breaks, any snacks, and then come back in about 3 or 4 minutes. If you want to stay and ask questions via the chat or by unmuting yourselves, you can do that as well. So let me know, and we will continue in about 3 to 4 minutes. I'm going to go ahead and pause my recording. Somebody remind me that I need to enable my recording again later on if I forget.
I'll remind.
Okay. And let's go on where we left off. In addition to looking how exposed our cloud is, in addition as to having a dashboard where we can see just the things that we want to see, and we can configure that, and we can look for, I want a list of all the route tables having changed, in the last hour or the last day. If we can do automatic remediation. So if somebody makes a change that we don't want, we can add a trigger to it to revert it and get it back to the way it used to be. One of the other things we can do is we can look and analyze the logs, and we can look and analyze the logs graphically. So this is the Activity Explorer. The Activity Explorer looks at CloudTrail logs, and then it gives you a graphical representation of what those logs are saying. In this particular case, I logged in as root. This is me. And it tells you, hey, somebody logged in as root with this identity, and they did it via the console, which is what I did. And then it will proceed to tell you exactly what was it that I did. And there's a timeline of exactly what I did and when I did it. So if I went in and says I list my load balancers, it will show that I did a describe load balancers to the load balancers groups. If I may be connected to an instance, I go into timelines, and I can see for that instance, I looked at the route tables, at the network interfaces, and I can tell you from here exactly at what time the request and what time the reply came back from. So we try to give you a graphical representation of the logs, and we enrich the logs. We add additional information to those logs as well. Now, another thing that we can do is the traffic, and I don't know if I enable traffic for these or not, but we're going to check it right now. And I may not have. Let's see if I can do 7 days. I may have some older logs in here. No, I don't. Well, just like we can do, and actually there's a different, I can go into a different demo to show you that in a second. But just like we did CloudTrail logs and CloudTrail log analysis, we can do flow log and connection analysis on traffic that has connected. We do this for 2 reasons. Number one, the firewalls do not see every single piece of traffic that flows in AWS. You can have 2 gateways that are completely internal. They never go through the checkpoint CloudGuard gateways for any reason. They talk to each other. We still want to be able to see those connections, and we can if we import the flow logs. We also learn a lot about the environment. So we learn a lot about the environment, a lot more than just what the flow logs have. So if you look at the flow logs, you're going to see that they have public IPs or private IPs, whether it was accepted, the time the connection, what port the connection was on, but it doesn't tell you what those IPs are. We know what those IPs are. We know when they're an instance, when they're a load balancer, when they're a Lambda function, and we actually can match what that object was at the time of that action. So you can now tell that it was a Lambda action that was reaching out to talk to an instance, or it was maybe a malicious IP talking in to a load balancer, because we can also check for outside IPs and whether they have good reputations or whether they're malicious, what country they're coming from, all that we add to the logs. So we enrich the logs, and then we actually run a number of rules against those logs. And this is showing multiple platforms. Let me just do AWS. In this particular case, we run anomaly detection against those logs. We look at access management. We look at discovery activity. We look at serverless traffic that may be suspicious. We looked at changes in identity and access management, or at changes in the keys. We look at collection activities. We look at defense evasions. We look at privilege escalation. We look at exfiltration data. We look at the discoveries and scans on the network. So you don't actually have to look at these logs at all. We bring them in, we enrich them, we run a lot of intelligence against them, and then we're going to give you alerts that we're going to show in here that are going to tell you when something has gone wrong that we detected via the logs. If you go to events and you go to threats, I can, let's change this to source intelligence, and change this to, we have it already, so we have some extra things in here that are blocking us from getting some good stuff. Okay. Intelligence is everything that we learn from the logs. So we have some activities like, hey, somebody's logging into your system using root. Maybe that's something that you don't want. Or somebody logged into the console without multi-factor authentication. That may be something that you don't want. Or you can see SSH activity. You can see traffic if you have that activity turned on. And we give you the dates that all these things happen. And when you go in here, you can say investigate. And if you do that, it takes you to that specific item in the logs, and it shows it to you via that graphical format. So you're going to see if a root logged in, this is everything that we know about that. Somebody used the root access. They went in through the console. They did not use the MFA. We can actually see the log equivalents of these as well and open them up. And we can see all the information that we grabbed from it. For example, this is not something that CloudTrail normally gives you. The actual user agent and the browser that was used for this connection, for example, right? We give you a geolocation as well. So we give you a lot of information that is not normally part of CloudTrail when we do things like this. Same thing if the issue was something that had to do with, let me do again all, and I think, well, yeah, I got intelligence still. Sometimes it has to do with malicious IPs or SSH activity that is not allowed. Again, outbound traffic to a specific destination. We tell you why we flagged it, the reason why we did, and what we think is an issue. So in this particular case, we identified outbound traffic via RDP to the internet. And if you have desktops in the cloud that are allowed to do this, that's fine. But if you don't, it means somebody created a Windows system in the cloud and is using that Windows system to RDP out into the internet, maybe to hide their tracks. So we normally tell you what is it that you're looking for, where is it that we found it, and then you can click on investigate to see the actual graphical version of the logs or to see the logs themselves. So this is a general review of some of the things that we can do. If you're running workloads, for example, you can actually look at the workloads, but let me actually go ahead and switch here because I want to show you the actual traffic so you can see how it looks. So I'm going to switch over to this one that has a lot more traffic examples. And I'm going to go back into intelligence, to log analysis, and I'm going to go to Traffic Explorer. And okay, so this is an example of traffic. We can see a malicious IP. We can see a malicious IP is connecting to something inside of our cloud. We can click on it and find more information about it. The malicious IP is connecting using ports 805 and 8803. They're connecting to a network load balancer. We can see information about the malware family here. It is a phishing attack. We can go into the timeline and we can see that everything is in one direction from the malicious IP towards the NLB, but the NLB is not answering. So while this is of concern, we're getting hit by a malicious IP, it's not really that much of an issue because that request is dying at the NLB. There is no reply that's going back. But we can see events that are high risk. So let me go ahead and see if I can see some that are recent. And let's go here and let's filter by log analysis. So source, intelligence, and let's do all. And oh, we are in the wrong. I want to be in AWS production. And okay, so actually I can browse by severity as well. And I think, yeah, we are from medium. Is this from medium? Actually, I think I did this the other way. I think this is from high to low. Yeah, so now we can see the criticals on top. We see the time we saw the critical event. We see the network that we were looking at, and we see the exact item that caused the alert. What it was a successful API request originated from malicious IP. That means not only a malicious IP connected to one of my API gateways, but the API gateway replied to it. So every time you see successful request from malicious IP address, that's what it means, and that is why it has a degree of critical. If we look at the traffic, do we have anything that is very recent? Oh, this is very old. Let me see if I can do one that's very recent. Oops, again, I'm sorting in the wrong direction. And the reason I want to do this is because I want to see something that is recent. Okay, inbound accepted traffic from malicious IP that happened today. I want to click in here. It's going to tell me the rule that triggered it. But if you remember, I can also investigate. And if I click on investigate, it's going to show me that visual representation of the traffic. It was a malicious IP. This is the, oops, if I click on malicious, I can see the malware family. It is a scanner. It is hitting me on ports 5683 and 6668. We can look at the timeline. Again, this one, again, it was also inbound. So we should be okay. But if I go to the logs, I get the full enriched logs for this system. So I can click on any one of these and I can see that, the IP is coming, is malicious, it's coming from the Netherlands, is hitting the network load balancer. So actually, sorry, the type is actually an application load balancer. All this information is not normally part of your flow logs. We add it to your logs based on the audit information that we collected from the cloud. So we can get you some added information. And by showing you the timelines and the graph, we try to make the attack a little bit easier to understand visually. So I know whether it was an answer or not. I know at what time things happened, what direction it was, the type of malicious IP. I can very quickly see that without having to going through lines and lines of ASCII or text logs. Okay, if you have workloads in the cloud, and by workloads, I mean containers. We also do a container analysis and scan. So you can look at the containers. We can not only see them, we rank them by how vulnerable or risky that container is, because it has risky code, it has malicious code inside of it. It is calling libraries that are vulnerable. So we sort of break down that for you, and we give the system a score, and we do a risk analysis. If you are function first, or you are heavily into serverless development, and we have some customers that 100% of their traffic is basically serverless functions, we can secure your serverless as well using this product. And we have 5 different protection engines that we run against serverless. We do the configuration. So we look at the code, make sure there's no credentials are hard-coded in or malware. We do vulnerability scanning. We see how vulnerable the code is, whether it's using a vulnerable library, or we actually see some opening in there for something to the outside. We look at the roles associated with the serverless, and we will basically rank. We will tell you if there's anything that we see that is of concern. If something is just right, we'll tell you it's green. If it's something of concern, we give it a red. We tell you low concern, but maybe something is critical. In this particular case, we analyze the Lambda. We see the Lambda only does one thing, but on S3s, but you have everything allowed to an S3. We will give you a suggested fix for that. So if you go in here, you can see that the only thing we saw this Lambda do on S3s is write to the S3s, do a put object. So we recommend that you change the roles from a star and everything allowed to just that specific action. So we give you an analysis of how permissive your systems are. Again, we also do runtime. So we look at what that Lambda is connecting to, what networks, what objects, what instances, and we look at the behavior. So if we saw a Lambda that all it does is it automatically backs up your database servers to a backup server, and then after 2 months, it starts connecting via SSH to something out on the internet, that is a behavioral violation. We will see it. And if you have blocked on detect checked in here, we will stop it. If you do not have blocked on detect, we will tell you this Lambda started connecting to somebody out on the internet on this date. And that's what these do. I'm going to go ahead and look at some of the threat detections that I've seen for this particular Lambda. I've seen it's calling API events that it shouldn't be talking to. It's getting a code injection attack. It is running processes that should not be running in here. You can expand any one of these. I'm going to expand this one, and basically it's telling me, it actually shows me the processes that were detected. It says when I created the function, all I saw this Lambda do was cats and LSs. And now it's trying to run this stuff, right? And it's telling you where we saw it, in what particular piece of the code we saw that function. So we can find out a lot of information about serverless traffic, and we will give you alerts on it using this particular system. If we go into posture, we will see violations that have to do with configuration or violations that have to do with the code. So overly permissive roles, excessive timeouts, credentials that are embedded perhaps in the code. And even though we see that you have credentials embedded, we do not collect those credentials. If I'm going to go here and actually go into the issue that we saw, actually, let me see if I see it. Sorry, an overview. Oh, credential users want to see the actual code. We just show you or collect the last piece of it, and we sort of obfuscated stuff. So your actual credentials are never part of our system, and they never come into the cloud. What you see is that we found a secret access key. We found it on line number 10. The value was, obfuscated, but it ends in NUD. So we tell you where to go look on the code for that embedded credential that we found, and we make that available to you. Okay, so we've hit almost everything in posture management. I'm going to go a little bit back to my instances and my cloud environment, because I'm going to talk a little bit about tagging and things that we can do with tags, and then we're going to wrap up. So let me open the Smart Console. Let me put in my password. And let's wait for this to open. Okay, so I got my cluster. As you see, my little red, green problem went away, and now we have everything green. We got our manager. We have our logs. We have our security policies. Our security policies from the lab, I think, allowed, rules for the web server, rules coming in for the cluster member VIP, and then we have our cleanup rule that we haven't changed, still in all accept. But the reason I wanted to come here is because I can use, instead of the web server, which I just created this object and entered here, I don't have to enter it, because if you remember, we are connected to the cloud. So I can go in here and say, I want to import an object from the cloud. I want to import it from my AWS data center 1. And let's see, here we're connecting, things are coming in. In instances, I see that my web server is going to be one of these. So I can just click on this, right? But I can do something that is a lot more powerful than just clicking on an instance name or ID, which is what this is. And then I can take a look at my tags. And I can see that I have systems that are tagged as a web server. In this case, one instance. That instance happens to be the web server. And I'm going to go back here into the cloud and show you web server and show you tags and bring this up. And there it is, value for, let me scroll this up, because I'm sort of hiding it from myself. There we go. Okay, one of the things that I did was I added a key and a value when we did the lab of key web and value server. So we have those. We can see these from the manager. The manager can see this. I can see that I have something that has a tag value of server and a value name of web, and I can use that for my rules. So instead of putting web server, I can just basically just add this tag, or I can say, let's see, go to tags, tag for name, tag value, name web server. There we go. Nope, that's not the value that I wanted. The training instances, subnets. Thank you. Tag value of server. Okay. That is going to add it in here. So I'm going to delete this. I want to remove it. And now, instead of using the actual object that I created, I can go ahead and publish this. I am using the tagged object. If I put my mouse in here, I can open this. Actually, I think I can do this and double click on it. And well, I'm not seeing the IP. We sort of remove that, but I'm pretty sure we're adding it back in. I can usually do a mouse over, and I can see the IPs associated with this object. I can see them because we see them in here. Let me go here, the center, AWS. And I can see the instances that are associated with this tag, and I can see the IPs that are associated with it. But let's make a change. So let's go to AWS and let's tag my manager. Actually, I'm going to tag my manager as if it were a web server. So let me go ahead and put tags, and I'm going to put here manage tags, and I'm going to add a tag, and the key is going to be web, and the value is going to be server, which is the exact same tag I believe I have for the other one. Let me see, for web server, tags. Yep, web server. So now I have two things that are tagged as web server that have that same tag value that we had before. So I'm going to go back to, okay. Sorry, I'm going to go back to here, and I'm going to take a look in here. If I look at my source again, let's say import data centers, AWS Direct Connect, and I see things that are tagged as a web server. I'm going to see two instances now. Before I was seeing only once, but now I'm seeing the web server, which is what I had before, but I'm also seeing the checkpoint manager, and now it's part of my list. So by having this here, this now includes the checkpoint manager as well as the web server, because both of them are tagged the same way. If I have this, if I already pushed this policy, I don't need to make any changes. I don't need to repush it. All I need is to delete or add tags into my systems, and they will automatically get added or deleted from a source or a destination. So again, that is a very, very powerful thing. Yes.
There's a couple questions in the chat.
Okay.
Sorry to interrupt you. Could you compare CloudGuard with Athena or Config offered by AWS?
Sure. There is a bit of overlap, just like we saw overlap between our firewall and the AWS firewall. There is an overlap between the things that the CloudGuard posture management can do and what we can do. We can usually do a lot more or get to be a lot more expandable than the equivalent AWS service. What I normally tell people is to do a test to enroll as a proof of concept with our system is free of cost. And you can actually see the data that we're collecting and the data that AWS is collecting for the same objects and items. And you will usually see differences. If you're coding your own queries, if you're looking for your own specific things, and I can give you an example. I had a customer that has literally tens of thousands of objects and multiple lines of business deploying things in AWS. Every now and then, when he wants to make a change in a subnet, he finds out that his servers are not the only things on that subnet. Somebody else dropped servers in there. He assumes it is somebody from his division, but he's not sure. So he wanted a way to keep track and make sure that everything in the cloud was tagged with a number of items, that the tags included the name of the administrator for that particular server. The tag included the accounting code that server should be built against, sorry. Maybe whether that particular asset contained private information that should be protected, or whether it should be part of an assessment that included maybe PCI or HIPAA or whatever the requirement was for certain systems. And they wanted a system to enforce it. We can create on-the-fly policies that enforce the tagging, including multiple classifications on a single line, and we can generate reports based on substring searches in there. So we could do things like, I want to see everything that has the accounting code 338 as, as digits 6, 7, and 8 of the format string. And I want to see everything from that accounting code that has been changed in the last 7 days, or that has access to RDP to the outside. We can get very, very granular on our checks, and we can look into things in ways that AWS just does not have the tools to do today, or the complexity of layering that we do today. So I would suggest, again, that you test us side by side, and you can see some of the things that we can do that AWS cannot. If your scanning is very basic, if you're not looking for things that are too specific, The base AWS tools may be fine, just like the base firewall is fine if you're not looking for embedded malware on data. But you will find that you can get a lot more granular and you can extract a lot more information and you can do a lot more complex reporting, or configure the dashboard views into that data in a much more complex and thorough way when you use our systems. Any other questions about the posture management or the tagging or deploying systems in AWS, or deploying using Terraform versus CloudFormation, or pretty much anything of the things that we talked about today? Something else on the chat? Oh, that's just a thanks. Well, you're welcome. Remember, everybody, you will be getting this recording or links to this recording. It may take a little bit of time to go out. I think that the Azure recording, which we did last week, is probably going to go out this week. So it may be a few days, but we're just cleaning things up a little bit before we send them out. You have the links to the recordings that I use as part of this demo, the ones that have no sound. You can see those, or you can use those since you already have the links. We will be sending those links again on the deliverable. So again, if you did not catch those, do not worry. I had a question about management. The question was, if you have a smart console already on-prem, do you need a separate management server in the cloud? The answer is no. Your on-prem manager can manage things in the cloud. If you want to move your management server from on-prem to the cloud, your cloud manager can manage your on-prem gateways. So we have customers that have their primary server on-prem and their standby server in the cloud, and vice versa. So you can use the same manager you have on-prem today to manage anything in AWS in addition to your appliances. And it can also manage things in Azure, and manage things in Oracle, and manage things in other cloud, and manage virtual gateways in VMware. So a single manager should be able to manage all your systems, because all the virtual systems we have running on the cloud are the exact same OS and the exact same software that we run in appliances. It is Gaia running the regular blades. They're just running them on a VM in the cloud or a VM on-prem instead of deploying them on an appliance. That's it. That's the only difference. Any other questions? Well, in that case, it looks like I'm going to give you about 20 minutes back or so. Thank you very, very much for participating on our bootcamp. Again, it's usually kind of difficult to make the boot camps both basic enough for everybody and complex enough for everybody that wants to learn. I have a question about your IP space and what it can be used in the cloud. And the answer to that is yes. That is usually something that is specific to AWS or Azure, but you can talk to the engineers and they will tell you how you can assign IPs of your own into the cloud. AWS loves it. Azure has tons of public IP address space. AWS is hurting for public IP address space. So every time a customer wants to use IPs that are public that belong to them versus using the AWS public IPs, you will most likely get a big hug and a kiss from your AWS representative. So yes, you can definitely use your own public IP space when you deploy in the cloud. If that was the last question, I want to thank everybody else again. You will be getting a copy of this recording. You will be getting a copy of the slides that I had at the very beginning. You will be getting copies again of the links for the specific recording of the exercises themselves and for the lab guide. Remember, the lab guide has a posture management piece that does not work outside of our lab environments. So exercise number 3 in the lab guide is the best example, but there are also exercises on the second part of that guide after the cluster has been deployed, after exercise 5, that also cannot be done because you don't have access to that posture management piece, but you can evaluate our posture management either on a lab or on your live network by just reaching out to us and just register yourself for that. It is free of cost. So you can do a full evaluation and you can compare us to any equivalent offering that AWS has, whether it's Control Tower, whether it's our system manager, it doesn't matter. There is a lot of overlap, yes, but for a lot of these posture management technologies, we have about a 2-year head start from AWS because AWS was reacting to the products that were doing this, and ours was one of the first ones off the gate. Okay, so thank you very, very much for participating. Again, you will also get a copy of my email. So any questions that you forgot to ask today that have to do with either AWS or Azure or Google or Oracle or VMware or ACI or OpenStack, if it's public or private cloud, I am a valid Checkpoint contact for it. So feel free to reach out to your Checkpoint team, or if it's cloud specific technical questions, to CC me on those. I like to be in there along with your regular team, because if we're having a conversation about the cloud and answering questions, your regular Checkpoint team should know what's going on. So I usually ask that you CC your local team whenever you send emails to me. Okay, I'm going to go ahead and stop recording. And thank you very, very much once again.